Bienvenidos todos a la charla virtual del miércoles de Ingeniería, Air Pollution and Health in Public Transport, organizado por la carrera de Ingeniería Civil de la Universidad de Lima. En esta oportunidad nos acompaña Bianca Dutra de Lima, licenciada en Química por la Universidad La Salle en el 2017. Cuenta con un máster y es estudiante del doctorado en teledetección con énfasis en ciencias atmosféricas por la Universidad Federal do Rio Grande do Sul, Brasil. Fue miembro del grupo de estudios ambientales y nanocomposites investigando sobre drenaje, discúlpame Bianca, investigando sobre drenajes de minas ácidas, carbón y cenizas. En esta oportunidad, en la charla se discutirá la ocurrencia de contaminantes atmosféricos en todos los ambientes y su posible daño a la salud humana, analizando datos de estudios realizados recientemente y mejoras estructurales que pueden contribuir a un sistema de transporte más seguro y sustentable. Cabe mencionar que la charla va a ser dictada en inglés. Las preguntas las van a poder realizar en inglés o en español al finalizar la charla. Entonces, Bianca, te doy pase, voy a compartir el archivo y doy pase a tu ponencia.
Obrigada. Thank you.
Listo, ya cuando quieras puedes empezar. Te escuchamos.
Okay. Hello, everyone. Thank you for having me. I am Bianca from Brazil, and today we're going to talk a little bit about air pollution and health in public transport. That's a field I've been working with for at least 6 years now. So it's a very pleasure to be here and talk to you about it. So today I have organized the topics of our conversation into atmospheric pollution and the urban environment, transports as microenvironments, human health risks, and possible improvements. Okay, so let's go. Let's start with a short review of the atmosphere. Basically, we can divide the atmosphere into 5 layers by temperature, with the last one being the coldest, of course. We can separate this atmospheric system into 2 stages. Basically, the lower atmosphere, studied by the science we call meteorology, and the upper atmosphere, studied by aeronomy. All these processes interesting to us for study of air pollution are concentrated basically in the lower atmosphere, okay, including the famous ozone layer that is located in the stratosphere layer, that is the second one. So the main area that interesting us for these air pollution studies is the atmospheric boundary layer, ABL, the lowest part of the troposphere, just above us, above our heads, above the surface. This layer has no fixed size, so it moves in response to surface. During the day, we have the condition we call unstable atmosphere. That is the left one, you can see. When there are mechanical and thermal disturbances, okay, wind and solar radiation, which stimulates greater turbulence and eases the dispersion of air pollutants. So that is the very better condition for us. The other condition happens at the night when we have just mechanical disturbance of the wind. So it generates insufficient turbulence to disperse these pollutants. So it results in accumulation of them in the breathing air. Okay, it is this in the right. You can see. So for us, talking about air pollution and dispersion and health, it's safe to say that we have a higher air pollution condition in the late afternoon to early morning period, which includes this stable atmosphere I just said. For us, to study air pollution, that's enough about atmosphere. That's enough for us to know about ABL, okay? So let's talk about atmospheric pollution and the urban environment. So by definition, air pollutant is considered any form of matter or energy that make the air improper, harmful, and inconvenient to human health. The public well-being, materials, fauna, flora, and the use of property, okay? Air pollutants can be of natural or anthropogenic origin, emitted directly into the environment, the primary ones, or formed through other reactions with other components. We call that secondary pollutants, okay? It's very easy. So in this table, you can see the main sources of the best known air pollutants. You can see that fossil fuels are responsible for the emission of several of these pollutants, such as particulate matter, sulfur oxides, nitrogen oxides, carbon monoxide, and others like that. And here we have the air pollution cycle, okay? Very easy to understand that. In the first stage, emissions from the source happens. Then in stage 2, there are 3 possibilities: dispersion or transformation through reactions to form other pollutants, we call secondary, or deposition, depending on the type of the pollutants involved. And finally, in the last stage, the third stage, there is the reception of this pollutant by a surface or a person or animal or plant or wherever. In the urban atmosphere specifically, the emissions mainly originate from fossil fuels, mainly. So, as you can see from the picture, we have 38% originating from exhaust and no exhaust emissions from cars and trucks, 21% originating from household, 18% originating from industry, and 23% from no-road vehicles, such as boats. Particulate matter, the PM, is the pollutant present in all types of emissions. That's because this is so important for air pollution studies. Okay. In addition, I think we have another graph. Yeah. In this graph from an article published in 2015, shows that traffic contributes large concentrations of particulate matter smaller than 10 micrometers, PM10, in different regions of the world, okay? So we have a very similar pattern over the world about PM concentrations and emissions by fossil fuels in urban areas. In addition to these outdoor PM10 emissions, there are a large number of indoor PM10 emissions emitted from sources inside homes, offices, schools, libraries, and transportation as well. The vast majority of these indoor emissions are composed of VOx and particles of VOx and bioaerosols, including bacteria and virus in some cases. So we have a very dangerous places indoor either. So therein lies the main issue of urban transportation. Is a specific condition of sharing an outdoor and indoor environment at the same time. So we becoming a mixed microenvironment. Thus, the people inside these vehicles are exposed both to pollutants from vehicular traffic, which enter through doors or windows, and to pollutants from inside the vehicle itself. Okay, so this is the problem. This is the biggest problem. We discussed this more now. Transports as microenvironments. In general, the use of this public transportation is very favorable from a socioeconomic and environment point of view, since it reduces the flow of vehicles on the highways and therefore their emissions. So we have just one vehicle instead many of them. It has a low cost for the population in general. It offers greater safety and high speed in the case of the trains. It can use an electric system without exhausted gases and greenhouse gases in the case of the trains too. And it enables the use of underground or elevated sections, increasing the use of the space. Also in the case of the trains. So trains are very, very, very better than other types of transportation in general. But about air pollution is not that easy. Because, however, exposure to these air pollutants is very increased because the users are exposed to pollutants from inside and outside at the same time. In addition, being close to the sources of these pollutants intensifies the exposure. So it can be more dangerous than when we are just inside home or outside. It is the two conditions at the same time and two pollutants at the same time. So here I show you basically the indoor air quality in urban transports depends on the ventilation system used and its maintenance, which can promote greater dilution, dispersion, or concentration of these pollutants inside the environments. To measure this relationship between outdoor and indoor pollutants, it's common to use the IO rate. Okay. In most articles you can read, you find this rate. As example, here I show the indoor of two transports, a bus and a urban train. In the bus, your left, the open windows promote greater infiltration of outdoor pollutants, but contribute to the wind and flow for particle dispersion. We call that environmental washing. But the common horizontal ventilation promotes an inefficient air renewal only every 10 or 20 minutes. So it is good for one way, but it is bad for another way, okay? In the train, in your right, air conditioning promotes better air filtration and renewal if cleaned regularly the air conditioning, what never happens, okay? Otherwise, dirty filters, that is common, contribute to the concentration of these particles. The closed windows don't let the wind flow, but also isolate the indoor environment from possible outdoor pollutants. So, again, we had a positive and a negative. There is no rule about it. Indoor air conditions depend on the set of ventilation and air renewal and this maintenance, okay? That's the only rule. And, okay, emissions depend very much and very much on the type of the transport, okay? Unlike buses and cars, which runs on the combustion of fossil fuels, trains have a different emission profile. While nitrogen oxide, sulfur dioxide, carbon monoxide, and PM are common pollutants for gasoline and diesel, the main emissions from these electric trains are PM related to mechanical friction and power transmission. Usually with many heavy metals and carbon. Other factors also influence the air quality of these environments, such as cleaning frequency, station architecture, vehicle composition, passenger density, speed, frequency, power and braking mechanisms, and others. Okay, so we have very different patterns depending on the type of the transportation. And what about the danger of these pollutants? In the image on your left, we get a graph from a 2020 article showing the daily concentrations of PM 2.5 in urban centers in South America, including Lima and São Paulo. As you can see, there it shows the exposure level recommended by World Health Organization is exceed in several cities such as Lima, São Paulo, Santiago, Medellín, and Bogotá. On the right, we have transmission microscopy images of nanoparticles found inside the closed urban trains of Porto Alegre, Brazil, in 2019 during my master's degree. So this was my work of master's. We found several heavy and toxic metals such as cadmium, lead, and chromium in particles smaller than 50 nanometers. That is fully respirable. And the consequences of that are dangers to our health. That is the next topic, human health risks. Of course, these pollutants are harmful to human health, obviously, but what defines this harm? What defines which ones are better or worse for us? In general, the levels of health damage depends on the exposure time and characteristics of the pollutants, such composition and concentration in the air breathed, okay? In this table, we have a summary of effects caused by some pollutants according to the time of the exposure. And currently, it's known that these damages go far beyond just the respiratory system as we knew years ago, okay? So, the damage depends mainly on the exposure time, the concentration of the pollutant, and the composition of this pollutant. Among the common pollutants found in public transportation, PM is the most bioaccumulative and therefore the most concerning for us, okay? These particles keep acting in the human body after the exposure, which can cause more serious damage to the lungs, blood, circulatory system, brain, heart, and even the reproductive system, okay? So far beyond the system, the lungs, the nose, and etc. Here above, I put a remark about COVID-19 because, as you know, since 2020, it is acknowledged the PM, particulate matter, as also carries the new coronavirus, as well as other known viruses and bacteria. So this is a real danger, a plus under danger. What I want you to understand is that in the study of the damage of air pollution to human health and environment, more than just the concentrations are important to study, okay? The doses of these pollutants are most important. So how can we say the dose of this pollutant is coming into our body? These doses depend on people's physiology and change according to gender and age, okay? Here, I show you concentration data collected in different transports of Barcelona in 2012, I guess, yes. And they compare with the doses that was estimated by a model, okay? As you can see, there is a difference between what is found and what is in fact breathed by the passengers and can be real related to disease. So the concentrations are important for us to understand, but the doses are more important than the concentrations, okay? And there's differences between them. So here we have another study, I guess from Europe in 2015, where the doses and concentrations are compared again. In the first graph, the doses related to 3 parts of the human respiratory system that was modeled, okay? So extrathoracic, tracheobronchial and alveolar interstitial regions of the respiratory system. Although the highest dose is obviously deposited in the outermost part of the lung, some of it reaches the innermost part, accumulating in that. So this is the bioaccumulated potential of PM, okay? In the two tables, it is possible to see that even with shorter exposure time to this PM, the dose is much higher in subway environments when compared to others. So this pattern was observed in several stations. So indoor places, more doses than outdoor places, okay? Especially the subway system environments. And so, what are the possible improvements? What can you do about it? In existing urban transport systems, some adaptations such as ventilation systems inside all buses, ventilation systems on platforms in railway environments, especially the underground ones, periodic maintenance of the air conditioning systems of buses and urban trains with cleaning or change of filters every 2 months, operation with windows closed with air changes every 1 or 2 minutes, and of course, and most important thing at all, stricter air quality standards, because in the Europe, the standards are very much stricter than in here in América do Sul, okay? And in the new urban transportation systems, take air quality into account right from the planning stage, okay? With this, include in the design, installation of PSDs in railway stations, those structures that isolate passengers from the tracks, use of granules and plants that contribute to the retention of this particulate matter in the passenger area, use of straight rails, no curves or inclines near the boarding platforms, investments in more modern buses and trains with systems that reduce fuel and energy costs, and mainly exhaust gas emissions, okay? So that's the plan. Consider air quality from the design stage is the easiest way and cheapest also. So that's it. Thank you guys. Thank you very much for having me.
Muchas gracias, Bianca, por la ponencia. Espero que les haya gustado a los participantes. Si tienen alguna consulta, alguna pregunta, la pueden hacer a través del chat. También, si desean, podemos activar los micrófonos. Las preguntas las pueden hacer en inglés o en español. Bianca entiende ambos idiomas. Así que, no sé, esperamos a ver unos minutitos si alguien en el público tiene alguna consulta. Igual estoy viendo que estás dejando tu contacto, Bianca. Entiendo de que también podrían escribirte para cualquier información, para cualquier consulta. No sé, a ver, el público, esperamos unos minutos si se animan a de repente consultarte algo. Voy a activarles también el audio.
Ok.
Bueno, Bianca, creo que no hay consultas. No sé si de repente la charla quedó súper clara. A ver, ahí tenemos a Gonzalo. Gonzalo está levantando la mano. Gonzalo, te escuchamos. Como te digo, Bianca entiende muy bien el español, así que te puede responder la pregunta en español o en inglés. Te escuchamos, Gonzalo.
Sí, gracias. Quería hacerle la pregunta de cuál crees que es la mejor opción para la mejora de este tipo de contaminación. O sea, la mejor alternativa.
Inside the transportation, the public transportation, I guess, ventilation, a more improvement ventilation system is the mainly one. Masks also help, but I guess that when we have more investments in ventilation sets and exhausting sets inside the transportation, buses, trains, it can possible to get better air quality indoor during the transportation. And for people health, I guess, ventilation set mainly.
Muchas gracias, Bianca. No sé si quedó claro la respuesta. No sé si desean hacer otra consulta. Como les digo, pueden hacerlo por micrófono, pueden escribirlo por el chat. Acá tenemos a Bianca dispuesta a responderles en español o en inglés. Bueno, en inglés, pero entiende muy bien el español, así que los escuchamos. Si está todo claro, no sé, Gonzalo, si respondió tu pregunta, si hay alguna otra consulta adicional.
Sí, gracias. Todo claro.
Thank you.
Bueno, creo que no hay más consultas, creo que todo quedó súper claro. Igual comentarles de que esta ponencia la vamos a subir a nuestra página de YouTube. Tienen el correo de Bianca, no sé si Bianca podrías de repente escribirlo en el chat. Quizás algunas personas desean contactarte de forma personal, ¿no? Quizás
Okay.
me da un poquito de vergüenza consultar acá, pero estoy segura de que teniendo tu contacto podrían acercarse para cualquier consulta, para cualquier tema de investigación. Entiendo que también estás para apoyar.
Sure. I will leave my email. So any questions, doubts, comments, whatever you want, you can contact me anytime.
Bueno, muchísimas gracias, Bianca, por tu tiempo, por la exposición. Esperemos que a todos los participantes les haya sido de bastante agrado la ponencia. Como les digo, vamos a cargar esta presentación en la página de YouTube de la universidad para que lo tengan a la mano. Nuevamente, Bianca, gracias por tu tiempo, por la charla y a todos los asistentes por estar presentes el día de hoy. Muy buenas tardes y
Gracias.
la charla. Gracias, Bianca.
Gracias. Bye.